In this video, I'm going to introduce you to our Cerebras reference implementations. To access to it, you can go to our documentation at docs.cerebras.net. In there, you will find a link to the GitHub public repository with our reference implementations. You will find two different models, BERT and FCMNIST, with implementations in TensorFlow and PyTorch. So last video, we learned how to port code from PyTorch to Cerebras systems using CVTorch. CVTorch is a Python module that grabs functions from Torch. We learned 4 different steps to use CVTorch: setup, data, model, and execution. In this video, we are going to go deeper into our reference implementations, and we will notice that there are 2 different types of folders. One that is called common, that's where we find all of the calls to CVTorch, and the second one that is specialized for each model, in this case BERT and FCMNIST. And inside this folder, you will only find code that is using Torch. So let's go deeper and let's learn how is that common uses CVTorch to handle the 4 different steps to our code. Common is an unified tool for our reference implementations. Our idea is that you can use the same code to run in CPUs, GPUs, and CS systems. To do that, we needed to distinguish between the code that runs in CPUs and CS systems. And we use 2 different tools to do that. The first one was defining a function called run. This function is inside run's utils.py inside common. This function run is imported in all of our model implementations, and it defines the model function, the data loaders related with training and evaluation, and the default parameters of your model. Inside run, there is a creation of a PyTorch-based runner. This is a class that is a wrapper for 2 different types of runners. The first runner is CPU, GPU enabled, and this runner is called PyTorch runner. This runner only runs Torch code. The second type of runners are the ones that are using CVTorch to run in the CS system. If you want to compile, you will use PyTorch CS compiler, and if you want to execute, you will use PyTorch CS runner. Regardless of the runner that you are going to use, you will find 3 functions. Create, that's where the creation of the runner is, where you specify the model and the parameters. Train, where you specify the data loader related with the data for training, and eval for the data for evaluation. So let's start with our first step, that is setting up. In CVTorch, we were using cvtorch.initialize, and this function, you will find it inside PyTorch base runner. The reason why is because it's the first instruction that we will always need to use when we use code for CS systems. The second step is data and model. And in there, we are going to use CVTorch data loader and CVTorch module to grab data loaders and modules from Torch. These 2 instructions are used in PyTorch CS runners and PyTorch CS compilers. In the last step, depending if we compile or we execute, we use 2 different types of CS runners. The first one uses CVTorch compile, and you will find that in PyTorch CS compiler. The last one is CVTorch session, and you can find that in PyTorch CS runner. With that, we have learned the 3 different PyTorch runners that we use inside our reference implementations, and that is what enables us to run in CPUs, GPUs, and Cerebras systems with the code provided in our GitHub repo. You can access to our reference implementations and more documentation at docs.cerebras.net. In our next section, we are going to go deeper into the BERT implementation using PyTorch in our Cerebras reference implementations. Thank you. Bye-bye.